Welcome to Industrial Evolution, where real engineering, real construction, and real industry shape the modern world.
17,000 concrete pillars, 1,500 kilometers of track.
This is the story of how engineers carved a railway through the second largest tropical rainforest in the Americas.
Beneath this jungle lies a geological nightmare. 85% of the route cross-karst terrain.
The solution: elevate the railway above the fragile ecosystem on 17,000 steel-reinforced concrete pillars.
42 electric trains built entirely in Mexico, waiting for their track. The race is on sale.
Construction begins in Chiapas, where the jungle is thickest. Survey teams have marked every tree.
Millimeter precision across 1,500 kilometers. Survey teams work in leapfrog formation, each measurement verified by satellite positioning accurate to within 2 centimeters.
Every 25 meters along the route, drill teams core samples to map the underground joints. Each core is tested for compressive strength, and the limestone must support loads exceeding 45 megapascals.
Foundation drilling begins with rotary rigs capable of cutting through solid limestone at 4 meters per hour.
Steel reinforcement cages are prefabricated on site, each one containing nearly 4 tons of rebar, arranged in
Installing a 25-meter cage required absolute precision. The steel must remain perfectly centered.
Concrete arrives at precisely controlled consistency, a slump of 180 millimeters.
In tropical heat, curing concrete demands constant attention. Thermal monitoring ensures core temperatures.
Modular steel formwork allows columns to rise in 3-meter lifts. The climbing system repositions itself.
Column reinforcement connects to the foundation through mechanical couplers, each one torqued to precise specifications.
Self-compacting concrete flows through the congested with minimal vibration. Sensors embedded in the formwork monitor lateral.
Across Section 5 alone, construction advances on 400 pillars simultaneously. Each pier cap is a structural masterpiece, and the hammerhead design distributes train loads evenly into the column.
Post-tensioning transforms the pier cap into a spring-loaded structure. The compressed concrete can now support dynamic. Steam curing accelerates the process. What normally takes 28 days happens in 18 hours.
Self-propelled transporters with 32 individually steered axles navigate the jungle roads.
The launching gantry is a traveling factory. It picks segments from below, carries them forward. 300-meter strands thread through ducts cast into every stress. When stressed, these tendons compress the engine. Each tendon receives 3,500 kilonewtons of force, enough to lift 350 tons.
With one span complete, the gantry advances in a methodical walking sequence. 800 tons of steel marches forward every 90 meters.
The elevated alignment preserves unbroken forest beneath. Wildlife corridors allow jaguars to piers.
Balanced cantilever construction advances from both banks simultaneously. Temporary cables hold each half in tension until the moment they meet.
The closure joint must align within 5 millimeters across an 80-meter cantilever.
The completed arch spans Mexico's mightiest river without a single support touching the water.
Where geology permits, the railway descends to ground level. The subgrade receives layers of compacted fill.
Rails arrive in 300-meter strings to minimize joints. Each string of 115 RE rail weighs 18 tons.
Elastic fastening clips grip the rail with 9 kilonewtons of force while allowing it to breathe with temperature changes.
950,000 tons of granite ballast will bury the track structure. The angular crushed stone locks together under train loading.
Tamping machines consolidate ballast beneath each sleeper using high-frequency vibration.
Before the railway can open, every meter must pass geometric inspection.
Flash butt welding eliminates rail joints. 40,000 amperes heat the rail ends to forging temperature.
Continuous welded rail must be stressed to a neutral temperature of 35 degrees Celsius. Too cold, and the rail tears itself apart.
Turnouts are the nervous system of the railway. Each switch allows trains to diverge to stations, sidings, or alternate routes.
The European train control system brings aerospace-grade precision to railway signaling. Trackside beacons communicate with trains continuously.
690 kilometers of the route will run under electric power. Catenary poles rise every 50 meters.
Each cantilever arm positions the contact wire exactly 5.5 meters above the rail. The contact wire, a solid copper-silver alloy just 12 millimeters thick, must maintain perfect tension across the entire electrified route.
Traction substations convert grid power to railway voltage at 30-kilometer intervals. Each station feeds both directions. The stations themselves are architectural landmarks. This latticed canopy at Tulum draws inspiration from
platform screen doors protect passengers and maintain climate control.
At Alstom's facility in Hidalgo, Mexican workers build the trains that will serve their own country.
25,000 volts flow through the pantograph for the first time.
The first wheels turn at 30 kilometers per hour. Every system is monitored, tracked.
Night testing reveals what daylight hides. Signaling visibility, headlight range, station approach lighting.
A railway is only as good as its maintenance. This depot will service every train in the fleet.
Three machines working in concert finish the final kilometers. Tamping, geometry correction, stabilization.
At Chetumal, the railway meets the sky. The station design curves like Caribbean waves. For the first time, trains operate across all 7 sections simultaneously. From a single room in Merida,
Every grade crossing must protect the public with absolute reliability. Warning lights, bells, and barriers.
Before touching an actual train, drivers spend 200 hours in simulators. Every scenario, from
Every train is inspected before every day of service. Brakes, wheels, pantographs, interiors, nothing.
At Chichen Itza, the railway serves history. The station design minimizes visual impact.
Palenque marks the western end of the journey. From here, the railway stretches 1,500 kilometers east and south.
4 years, 40,000 workers, billions of dollars. From the first tree cut to the last rivet-driven ring.
Inside the Shinball, the walking train, passengers experience what engineers designed. Panoramic windows frame the jungle.
On the Janal train, the journey itself becomes a destination. Regional cuisine prepared in onboard kitchens. The Patal overnight service transforms travel into rest. Passengers board in Palenque, dine as the
railway serves more than tourists. Students reach universities they couldn't commute to before.
A transcription opens with a male voice speaking, likely an announcer or narrator, lodging the line.
At full operation, 28 trains circulate the network simultaneously. The wheel lathe reprofiles them within 1/10 of a millimeter, restoring the geometry that maintains safe, smooth operation.
Overhead wire maintenance requires working within meters of 25,000 volts.
Beneath the railway, wildlife moves freely. Camera traps document jaguars, tapirs, and
Construction uncovered over 105,000 artifacts along the route. More archaeological discovery in 4 years.
At major junction stations, connections are guaranteed. The system tracks every train in real time.
Station canopies serve double duty, shading passengers while generating solar power. The lattice design that evokes ancient.
The railway employs 7,000 people, most hired locally.
International visitors step off aircraft and onto trains within minutes.
As evening falls, the day's final departures carry passengers toward distant destinations.
The railway's story continues. Freight extensions to Chetumal Port, industrial connections near Escarcega. From Palenque in the west to Cancun in the east, south through Chetumal and back through Campeche.
Grandparents remember when this journey took days. Parents recall hours behind the wheel. Children know only the train.
The train approaches Chichen Itza City, modern engineering bringing visitors to ancient engineering.
Journeys end at Cancun. Passengers are arriving from across the peninsula, some heading to aircraft, others to hotels.
After the last train, the stations rest but never close. Maintenance crews prepare for tomorrow's service.
34 stations now connect what was once divided. Tourists reach Chichen Itza in hours instead of days.
$10 billion, 6 years of construction, 120,000 workers. The numbers tell only part of the story.
Every arrival is a beginning. From space, it would appear as a single thread stitching together one of Earth's most remarkable regions.
This is what $10 billion looks like, not in steel and concrete.
Subscribe to Industrial Evolution for more videos exploring how the modern world is built.